We're solving by substitution. So before you did it with your calculator, and now we're doing it algebraically. You're going to see this on standardized tests a lot. They want you to know how to do this. So it's a good skill to practice. So these are the steps. You can read through it, but sometimes it's better to just do it. So we're going to do it. So we have these two equations. And right before, you would just graph it on your calculator and find out, where the points intersect. But now we want to solve it algebraically. So the first thing that we're going to do is solve one of the equations for one of its variables. So what does that mean? It basically means get x equals or y equals by itself. Okay, so this one, it's lucky they already gave it to us, right? They already gave us x equals -6 plus 2y, but sometimes you have to maneuver it about. So for this one, they already gave it to us. So I'm going to use the color x equals -6 plus 2y. So I'm just going to make a note. They already did this for us. Okay, step 2 is now we're going to substitute this expression into the other expression. So we have this expression right here, and we're going to replace it with this one, right? So pretty much, I'm going to rewrite the equations here, but with some color coding. So we're just plugging in this x and we're replacing it, right? So we're going to now write our new equation. We're going to have 4, make sure we have our parentheses, -6 plus 2y plus 6y equals 4. Right, so we just took this x that we solved for in step 1 and we replaced it. And now we have an equation that only has one variable. And remember, since there's only one variable, we have one solution. So we're going to distribute this out and solve for y. So we have -24 plus 8y plus 6y equals 4. We're going to combine like terms. -24 plus 14y equals 4. We're going to add 24 to both sides. Sorry, we sort of ran out of room. We have 14y equals 28. And then we divide both by 14. We get y equals 2. So this y can be in purple, I guess. Okay. So now we substitute again. So now we have y, and we're going to put it in to figure out x. So this is sort of like y equals mx plus b, right? We had an x and a y and an m, and we used it to find b. And now we had an x, we found y, and now we need to find x again. So if we're going to color code it, we have 4x plus 6, and you're going to put in your 2 equals 4. And you could do either equation. So I'll do the other one too. X equals -6 plus 2. Either one. You can do either equation. Can do either equation. And now we're going to solve for x. So we have 4x equals 12 plus 12 equals 4. We're going to minus 12 from both sides. We get 4x equals -8. So we get x equals -2. And this is the same thing, x equals -6 plus 4, x equals -2. So our final solution, we're going to write it as a coordinate point. So we're going to have -2, 2, right? And we can check this. We can check with our calculator, and we can check by plugging it in. Right? So if I had 4, -2 plus 6, 2 equals 4. So -8 plus 12 equals 4. This is true. And then I can check the other equation. -2. That's the equation. -2 equals -6 plus 2 times 2. So -2 equals -6 plus 4. This is true. So you can check it algebraically, or you can even check it with your calculator, but then you have to turn them both into y equals. You have to get into slope intercept. So you can check either way. And so I want to have a note over here, right? We have this system. This is called a system with two equations. If I had 3 equations, a system with 3 equations, there'd just be another equation, right? So however many variables there are is how many equations you need to solve, right? So if I had 3 variables, I'd need a system of 3 equations. So if I had something like 3x plus y equals 4, 4y minus z equals 1, I would need another equation to figure out these because I have x, y, and z, but only 2 equations. So I'd need like a third equation. So this is something that you're going to come across in other math classes. But when you see systems, however many variables you have is however many equations you need to solve everything. All right, so let's do an example. We're going to do 2 together, and then you can do 3 on your own. Okay, so for this one, step 1 is already done. And so we're just going to plug this y in. So we're going to have negative 2x plus 4, negative 7 minus 3x. And you want to be careful, like make sure you have your parentheses because the negatives are going to all get mixed up, right? Equals 0. So we just had this equation and we just replaced it with the y. So we have negative 2x minus 24 minus 12x equals 0. We combine our like terms, negative 14x minus 24 equals 0. We add 24 to both sides. Wait 1 second. This is a 28. My bad. Add 28 to both sides. Negative 14x equals 28. So we get x equals negative 2. And then we have to go back in and plug it in. So I'm going to take this first equation, but remember, it doesn't matter which one you do. So I have y equals negative 7, negative 3 times negative 2. Y equals negative 7 plus 6, which means y equals negative 1. So our final answer is going to be negative 2, negative 1. And you can check that by plugging it in. Okay, so I want you guys to try 3, 4, and 5. All right, so for 3, this one looks a little tricky, but they already did step 1 for us. They already have x, so we're actually just going to set these things equal to each other. So we have 2y plus 5 equals 10 minus 3y, and now we can figure out y. So we minus, you can do this in a few different orders. So we have 2y equals 5 minus 3y, add 3y, 5y equals 5, we get y equals 1. And then we go back in, x equals 2 times 1 plus 5, x equals 7, so it's 7, 1. This one, sometimes it's hard to see, but they did step 1 for us already. We have y here by itself, so we're going to plug that in. We'll start using colors again. So we have 2x minus, and you need your parentheses here. A lot of people forgot the parentheses, and then they didn't distribute this negative to this negative 1. So we have 2x minus x plus 1 equals 5. We get 2x minus x is just x, and then we minus 1 on both sides, so we get equals 4. And then we plug it back in, right? So we have x equals 4. So we have 4 minus 1 equals y. We're doing this one right here, the top equation. So then we just have plus 1, or wait, we don't need to do that. 4 minus 1 is just 3. So y equals 3. So we have 4 comma 3. And then the last one, this is the first time that they didn't give it to us nicely. We had to figure out step 1 by ourselves, right? So step 1, we have to figure out, we have to make one of these. So this one's probably going to be the easiest. We're going to move y to the other side. So x equals 3 plus y. But you could have done any of them. You could have done this one. You could have done y equals 2x minus 5. It doesn't matter which one you solve, but you want to look for the one that's easiest. So we're going to take this guy. We're going to put him in the other one. So 2, 3 plus y minus y equals 5. Distribute this 2. 6 plus 2y minus y equals 5. Combine like terms. 6 plus y equals 5. Minus 6. We get y equals negative 1. And then we go back in. So x minus negative 1 equals 3. So be very careful here because we have two negatives. So x plus 1 equals 3. So we have x equals 2. And our final point is 2, negative 1. All right. So that is it for solving systems by substitution. Hopefully the colors help.